So,
So 1/8.
good afternoon guys,
That's what?
welcome to NEET World Institute and NEET World YouTube channel. Yes, in this class we are going to concentrate on this class 12th IPE. There is very short answer questions. So moving charges and magnetism and and matter, that's the topic in last class also we have seen, and today's class also we are going to continue with those questions. Okay, and if we talk about the first question of this class is, what is the importance of Oersted's experiments? The importance of Oersted experiments, like what you told us, like you have told us, every current carrying conductor, right? Every current carrying conductor produces a magnetic field. So if we talk about any current, carrying conductor, so let me take a conductor. So a charge particle is flowing. So let me take this current I.
And
so conductor produces a magnetic field around us, which is perpendicular to the current carrying conductor. That's the thing you have told. What's the thing is told? Every current carrying conductor produces a magnetic field around it, which is perpendicular to the current carrying conductor. Got it? Next one, what is the force on a charged particle of a charge q? Charged particle on a charge q moving with a velocity v. Like when we talk about a charge q going with some velocity v in a uniform magnetic field of induction B. So what is the relation? They are asking. So relation, it is nothing but F is equals to BQV sin theta. BQV sin theta. So when we talk about it is maximum, so sine 0, 30, 45, 60 and 90. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Right. So when we talk about a sine, the value is increasing. At which value it is maximum? At 90 degree it is maximum. So when does it becomes maximum? So when the angle becomes 90 degree, it becomes maximum. Which angle, sir? Sir, we will about BQV. No, velocity is a vector quantity. And what about the magnetic field? Magnetic field V is also a vector quantity. And what about Q? Q is a scalar. No need to talk about that. So Q into B cross V. Q into B cross V. Okay. So the angle between B and V, if it is 90 degree, then the force will be maximum. That's the second question telling.
what is given?
Got it? That's the second question is telling to us. And what about the next question? State Ampere's law and Biot-Savart's law. Two laws.
And they are telling what?
Law and Biot-Savart's law. Okay.
8% law.
We can take a first two questions and we can go for the next questions. Okay. Next questions.
More.
Right?
Multiply by what? Denominator. Yes.
Done. Can we go for the next questions? Okay guys, we'll go for the next set of questions. And the third question, they are asking about what is Biot-Savart's law and what is the Ampere's law. Biot-Savart's law and the Ampere's law. Ampere's law is nothing but it's a line integral. The line integral of a intensity of a magnetic induction around a closed path. Yeah. So it's a line.
How much? Selling price.
Intensity of magnetic field index is around a closed path is equal to
minus selling
not in the total current enclosed in it. Okay, so it's a line integral of B dot dl is equals to mu naught times I. Okay, so what is mu naught? It's a permittivity, right? And Biot-Savart's law. Biot-Savart's law states that intensity of a magnetic field induction, due to which one? Small current carrying conductor, Biot-Savart's law. So the intensity of the current carrying conductor is talking about in Biot-Savart's law, right? Talking about in Biot-Savart's law. Done. So directly proportional to the strength of a current. If current increases, yes, obviously it will increase. Directly proportional to the length of the element, length, current, everything, right? And directly proportional to the sine angle. If sine angle, like the angle between them, increases, then that also will increase, right? Inversely proportional to the distance, the square of the distance of the point. So which means directly proportional to I, L and the angle theta. So dB is directly proportional to I into dl into sine theta by r square. So to remove the proportionality, we are adding a constant called k. So the formula is magnetic field induction, okay, is equals to mu naught I dl sine theta by 4 pi r square. So this is about the Ampere's law and the Biot-Savart's law, right? Yes, once you have completed, we can go for the next questions. Done. Okay guys, the next question.
To remember this way, otherwise
Yeah, circular coil of a radius r having an n turns carries a current I. What is the magnetic moment? Magnetic moment they are asking. So when we talk about a radius r, no, the circular coil of a radius, r having an area pi r square, n turns, so into n into pi r square, current I. So this is the answer, that is the answer, magnetic moment, n pi r square I, that's it, Ni into pi r square. Got it? Next one, what is the principle of a moving coil galvanometer? When a coil carrying conductor is placed in a field, no, it experiences a torque and hence deflect. So when a torque is there, obviously the deflection will take place. So therefore the current coil is directly proportional to the deflecting angle. How much the current is flowing, that much the angle will deflect. So what is the smallest value of the current that can be measured with moving coil galvanometer, that is a tangent galvanometer? Two things they are asking. The smallest value that can be measured with a moving coil galvanometer is 10 power 9 ampere. 10 power 9 so, in the sense
cost
0.000000123456789, right? 0.000001 ampere. And what about the tangent galvanometer? It is
this increase profit
0.001. Okay, that's the smallest value that can measure. How do you convert a moving coil galvanometer into ammeter? So excuse me, when we are talking about moving coil galvanometer into ammeter, no, just by connecting a small resistance, that a low resistance, okay, which is connected in parallel for that. Okay, so like moving coil galvanometer can be converted into ammeter by connecting a low resistance in parallel. So this is about the 7th, 4th, 5th and 6th, 7th questions. Okay, you can take a look of this questions and we can go for the next set of questions.
let us this as
So whoever having doubts or anything, no, you can ask through the comment session and we can discuss that. Okay. Okay, we can now go forward with the next questions.
59.
The last question,
Let me go.
how do you convert a moving coil galvanometer into a voltmeter? So when we are converting a galvanometer into ammeter, we are connecting a parallel resistance, a low resistance which is parallel. Similarly, here what we are doing, galvanometer into voltmeter, low resistance in the sense high resistance into parallel in the sense series. That's the thing. So when we are having a low resistance and we are connecting to the parallel, we are getting a ammeter. When we take a high resistance and we are connecting in a series, we are getting a voltmeter. That's the difference between moving coil galvanometer into ammeter and a moving coil galvanometer into a voltmeter. Okay, so this is about this chapter. That is very short answer questions of this last two lessons. I mean, the moving charges and magnetism and matter. Okay, and this chapter is moving charges and magnetism. In last class we have discussed about magnetism and matter, right? So with this we will conclude this very short answer questions in moving charges and magnetism, and we'll come up with the next chapter in the upcoming session. So thank you guys, we'll meet in the next class.